Okay, this is Mr. Peterson. I'm a teacher at Gardner Edgerton High School in Gardner, Kansas. And in this video, I'm going to show you how to solve three variable systems of equations. There's going to be a second video where I show you how to organize it on regular notebook paper, but there's only going to be two examples here. They're long problems, and because of that, you have to work very carefully. Okay, so here's the goal. We've got this triplet of equations, equation A, B, and C, and there's three variables, three unknowns, x, y, and z. So our goal is to find those unknowns. We have to find an x value, a y value, and a z value that satisfy all three equations at the same time. Now I'll give you a peek at the answer here. The value x equals -2, y equals 3, and z equals 5 are the answers. And here's the check for equation A. And you can see that, well, when we put -2 for the x, 3 for the y, and 5 for the z, you get -4 plus 6 would be 2. 2 minus 20 would be -18, so the first equation checks. All right, and the second equation, when you plug it in, same values. You have an x value of -2, so we put -2 in where it used to say x. And then we're going to replace the y with a 3 and the z with a 5. And that leads to -6 minus 3 is -9. -9 plus 5 more is -4, and that's the right value. So it works in the second equation. And then you can slow the video down and pause it if you want. But here's where I show that it works in the third equation. So the triplet, -2 for x, 3 for y, and 5 for z, is indeed the solution. So how in the world do you find those numbers? Well, that's my goal here, is to show you how to find them. Okay, step one, or stage one, is to eliminate the x from two pairs, and I make my students use A and B and A and C. So I have them ready to go here, side by side, A paired with B and then A paired with C. And you're going to get rid of the x in both equations. Now the goal here is to make the x cancel. Well, if you look at the x in the first pair, we've got a 2x and a 3x. The least common multiple of those numbers is 6, so we're going to put a 6x on the top line, and we want to shoot for its opposite below it. So to make the top line have a 6x, you'll have to triple that whole top line. We'll do that in a minute. The bottom line currently has a 3x, and we want it to become -6x, so the multiplier on that bottom line is -2, and we'll distribute that through the problem. Okay, so after you distribute here and get the first one, the next one would be plus 6y, and then minus 12z, and then remember to multiply it on the other side also to balance the equation, and you get -54 over there. That's what 3 times -18 is. Okay, across the bottom, we'll do that quickly. Okay, now the goal is to add these lines. Sometimes this is called the addition method, and that'll cancel the x, which was our goal. -46 is what those numbers add up to on the right. Okay, we basically repeat the process on the other side. We're helped out a little bit here on this one because 2 and 4 have a least common multiple of 4. So we're going to shoot for a 4x on the top line, which will require us to double that top line. And the bottom line, -4x, is actually good to go. You can see that it already has the -4x in the right position there, so we're not going to change anything there. It makes it easy. You just copy that bottom line. Okay, so that's just a copy of the bottom line. No changes needed there, but we'll have to distribute this 2 up here. And that'll take us to plus 4y minus 8z equals negative 36. Okay, when we add these lines, the x cancels or is eliminated, and that's what we were trying to do. Okay, at this stage we have we've eliminated the x in both sets of equations, and our system of equations has boiled down to 2 equations with 2 variables, which is a much easier system to solve. And to continue here, I'm going to label these. I usually call this first one here the star equation and the other one the double star equation. Okay, we'll continue with these 2 equations on the next slide. So here comes stage 2. Eliminate y by using the results of the previous stage. So we're going to take the star and the double star equation that we just found a minute ago, and we're going to put them above each other like so. And then we're going to eliminate the y value. Now the least common multiple of 8 and 7 is 56. So I'm going to go with a 56y here as my goal, and its opposite so that we'll cancel those later. Okay, the top line to make it a 56y has to be multiplied by 7. And when you do that, you get 56y minus 98z equals negative 322. The bottom line, to get the correct value that we're shooting for here, we want a negative 8. That'll give this negative 56 that we want down there. And that, when you do it, gives, multiply it through, gives 80z. And on the other side, 8 times 29, let me see what that is on my calculator. 232. Okay, we're going to add these, and it will eliminate the y, which is our purpose, and we get negative 18z equals negative 90. Okay, stage 2 is over. We've eliminated the y. You can probably anticipate what I'm going to do next. Stage 3 is solve for z. So here's where we left off, and I'm just going to divide both sides by negative 18. This is a very easy step. So we now know that the value of z is 5, and that actually is the hardest part, is finding that first value. The way I've prescribed, you're going to always find z first. Okay, so what do you do with that z value to continue? Well, you plug it into the double star equation, and that'll help you find y. So let's do that. 7y minus 10 times, I think we had a 5 as our value, and then that equals negative 29. So here you get 7y minus 50 equals negative 29. Adding 50 to both sides takes us to this, and a little bit of dividing here gives us a y value of 3. So now we know y is 3, and we found out earlier that z was 5. So you take both of those pieces of information and plug it into equation A. And this should be enough for you to find the x value. So let me consolidate a little bit here. This is 6 minus 20, negative 18, and negative 14 is the result we get when you simplify there. Adding 14 to both sides gives negative 4, and dividing by 2, we've got our final answer, negative 2. Okay, the only thing that's left here is a little bit of checking and some formatting. You should plug the values into equation C. That's not the one you just used. You used equation A to find the last value. You should switch to one of the other ones. I use equation C when I do this. And it does check. You can read the work there. And then you finally put the answer in coordinate format with the x first, the y second, and the z following, commas separating, and parentheses around it. Okay, so that's how you solve three variable systems. So it's a long process, and once again, I'll emphasize that you have to work very carefully because if you make a mistake, these are very hard to find the errors and very hard to fix. So just work slowly and methodically. And the next video, it'll look very different. It'll look like notebook paper. I'm going to show you how to organize your problem on note paper. So I'll see you on the other side here in video number 2.